Hello everyone. Today we'll discuss about the blood. What is blood? Blood is a fluid connective tissue which is circulated in the closed system. If you see the introduction of this blood, if you see it's undergo for so many functions. Blood is a fluid connective tissue which is circulated in the closed system. It undergo for so many functions and it participated in the blood. Respiration. The respiration, in case of respiration, the gases transportation like oxygen and the carbon dioxide. And next one is tropic action. The tropic action is nothing but the nutritive substances which are transported by the blood after the digestion and during the absorption. And next one is excretive function. The excretive function, in case of this, after the metabolic action in the cells and the tissues, the metabolic waste is transported by the blood. And next is regulative function. It regulates water balance, it regulates optimum temperature, it regulates pH and the acid-base balance. And next one is in case of the homeostatic function. So blood maintains homeostasis as it transports different kinds of the systems. So like it maintaining the temperature, it maintaining acid-base balance, it maintains water balance so that it undergo for the homeostatic function. And next one is protective function. So this blood is responsible for the immunity and the defense mechanism. During any foreign body enters into the body, it undergo for the defense mechanism and there is antigen antibody reactions. So that is because of the WBC which is present in the blood. And next one is the maintenance of the body temperature. As we discussed already, it maintains body temperature. Okay, and next one is the blood is about 6 to 8% of the total body weight. In case of the normal person, the normal adult men, that is about 70 kgs of person, about 5.8 height. Okay, so in case of that person, it is about 6 to 8% of the total body weight it takes. And next one is the total blood is about, the amount of the blood is about 5 liters in case of the adult men, and in case of female it is about 4.5 liters. It is less in case of the female and it is more in case of the male because testosterone increases the erythropoiesis process. So the erythropoiesis is nothing but production of the RBCs. And whereas come to the females, estrogen suppresses the erythropoiesis process. And next one is circulating blood volume is always lesser than the total blood volume because the peripheral resistance is the main reason for this. Circulating blood volume is less in case of the when it compared with the total blood volume. And next one is hematocrit. What is this hematocrit? In the sense, the percentage of the RBCs is called as hematocrit. And the RBCs, so when we'll centrifuge this under a tube after the collecting the blood, and then the RBCs comes as a supernant part is the plasma and the middle part is the Buffy coat and the remain part, okay, so the completely inferior part is the RBCs. That is what the hematocrit is, nothing but packed cell volume it is. This is about 45% of the total test tube. And next one is the white layer in the middle that contains WBC and platelets. And the supernant part is nothing but the plasma, it is a straw colored fluid. And next, if you see the composition of the blood, it contains plasma and the cells. Formed elements, it's also called as plasma is a fluid part and the formed elements are nothing but the solid part it contains cells. In this we have RBC, WBC and platelets. In case of the RBC, there is no further dividation, just it is a RBC. These are also called as erythrocytes. And next one is WBC. these are divided into two types. One is granulocytes and another one is agranulocytes. Granulocytes are again divided into three types. One is neutrophils, another one is eosinophils, next one is basophils. And after that, agranulocytes are in two types. One is lymphocytes and another one is monocytes. And platelets, these are also called as thrombocytes. And next one is hemopoiesis. Hemopoiesis is nothing but the production of the blood cells is called as hemopoiesis. So there are different types of the cells. Generation of the RBCs is called as erythropoiesis. Generation of the WBCs is called as leukopoiesis. Generation of the thrombocytes or the platelets is called as thrombopoiesis. And the formation of the blood cell components, and this is by the pluripotent hemopoietic stem cell. The pluripotent hemopoietic stem cell is nothing but when it committed to give a stem cell which is committed for the blood cells. And here this cell is about 20 microns. And if you see the hemopoiesis process, okay, so the pluripotent stem cell, and by that there are four cells, and one is committed through the committed cell, the CFUE, colony forming unit for erythrocyte, colony forming unit for megakaryoblast which gives platelets, and colony forming unit for granulocytes and the monocytes, and colony forming unit for lymphocytes. And through the colony forming unit E, erythrocytes production, that is what erythropoiesis. CFUM, colony forming unit for megakaryoblast which gives thrombocytes, and colony forming unit for GM which gives granulocytes, three types of the granulocytes and the monocyte. And another one is colony forming unit for lymphocyte which gives lymphocyte. And next one is regulation of this hemopoiesis by the mainly three types of the hormones. One is erythropoietin which regulates erythropoiesis process, and leukopoietin which regulates the WBC production, leukopoiesis, and next one is thrombopoietin which regulates the thrombopoiesis. Erythropoietin for erythropoiesis, leukopoietin for leukopoiesis, and thrombopoietin for thrombopoiesis. And next, so the blood plasma. So if you see the plasma composition, the 90 to 92% of the water is present in case of the plasma, and 8% of the solids are present. In this solids, the proteins are the main component, that is about 6 to 8%, and the dry substances are like organic and inorganic substances. Inorganic substances is nothing but the minerals, so which are divided into anions and cations like sodium, potassium, chlorides, fluorides, magnesium, calcium, zinc, like these substances. And next one is organic components are the carbohydrates, lipids, proteins, and the gases, enzymes, hormones. And concerned to the blood groups, the antibody is present in the plasma. And next one is, if you see the plasma volume, water is about 92%, and next one is coagulants is about 4%, and non-albumins are about 36% of the plasma proteins, and 60% of the albumin is present. And next, the blood plasma is mainly divided into, solid part is divided into cations and the anions. So if you see that, so the another one is organic components, that's about proteins, lipids, and the carbohydrates. And next one is the plasma proteins are in three types. One is albumin, next one is globulin, and next one is fibrinogen. The albumin is about the total protein content is about 7.3 grams per deciliter, and the albumins are about 4.6 grams per deciliter, and the globulins are about 2.6 grams per deciliter, and the fibrinogen is about 0.3 grams per deciliter. And next one is the lipids and the carbohydrates in the plasma. If you see this, the glucose is about 3.3 to 5.5 millimoles per liter. And next one is hormones, enzymes, pigments and the vitamins are present in this. And body's activity and the different physiological states are maintained by this levels. And serum. What is serum? What is the difference between the plasma and serum? Plasma contains fibrinogen and serum does not. So that serum is nothing but plasma without fibrinogen. That in the sense serum is equal to plasma minus fibrinogen is called as serum it is. And next one, if you see the pH of the blood, that is about the normal pH is about 7.45 to 7.35. So averagely it is about 7.6. Okay, and if it is less than 7.3, that is called as acidosis, and if it is more than 7.5, that is called as alkalosis. And next one is viscosity. The viscosity is nothing but density or the thickness. This is 5 times more than the water. This viscosity is mainly depends upon the components like RBCs and the plasma proteins which are present in the blood. And next one is the specific gravity. Specific gravity is relative density it is. So this is about 1.05 to 1.06 grams per deciliter it is, and it is also depends upon the RBCs and the plasma protein levels. And next one, the erythrocytes come to the formed elements. After the completion of the plasma, come to the formed elements or the solid part of the blood components. So that is the first one is erythrocytes or the RBCs. These are red in color because of the presence of the hemoglobin, and these are about approximately 4 to 6 millions are present. And next one is the lifespan of the RBCs is about 120 days, and the cycle of the circulation for the RBCs is about, it takes 20 seconds for each cycling of the RBCs. And next one is, if you see the structure of the erythrocytes, the normal range of the erythrocytes in case of the males, that is about 4 to 5 millions per cubic millimeter, and in case of the females, that is about 3.5 to 4.5 millions per cubic millimeter. And next one is the functions of the RBCs, like transportation of the hemoglobin, and next one is carbonic anhydrase. If you see the transportation by the hemoglobin, it transports gases and the carbonic anhydrase in the state of that. Okay, and next, erythropoiesis. What is this erythropoiesis? Erythropoiesis is nothing but the generation and the development of the RBCs. If you see this generation and the development of the RBCs, it is stimulated by the factors like 2 types. One is central factors and another one is general factors. General factors like hypoxia and the anemia and low level of the oxygens and hypovolemia. And next one is, so the whole process, it takes about the 7 days. And next one is, it takes about the 2 millions per second. The generation of the erythropoiesis, the red blood cells, it takes about the 2 millions per second. And next one, if you see this erythropoiesis process, first stem cell, this is about 20 microns, and that gives pluripotent stem cell. So which is committed for the blood cells is called as pluripotent stem cell. This pluripotent stem cell, when it is committed for the blood cells generation, it is undergo for the committed, that cell is called as what? Committed pluripotent stem cell it is. And this committed pluripotent stem cell gives 4 types of the cells. In that, the first one is colony forming unit for erythrocyte. This colony forming unit for erythrocyte gives only a colony which gives erythrocytes. And after this process, so this CFUE gives proerythroblast. The proerythroblast size is about 14 to 16 microns, and the formation of the hemoglobin starts in this level. in case of the proerythroblast stage. And next one is this proerythroblast gives another cell, that is what we call as early normoblast. This early normoblast cell gives intermediate normoblast, and in case of the intermediate normoblast level there is appearance of the hemoglobin. And the appearance of the hemoglobin in the intermediate normoblast and the production of the hemoglobin in case of the proerythroblastic stage. If you see the size of the intermediate normoblast, so that is about 12 to 14 microns. And nucleus is present in case of the intermediate normoblast. In all the levels till the reticulocyte, nucleus is present, and in case of the erythrocyte there is disappearance of the nucleus. Okay, and here come to the point, intermediate normoblast gives late normoblast. There is complete formation of the hemoglobin, mesh-like structure is formed and everything is seen. The size is about 10 to 12 microns. And next one, reticulocyte, which comes from the late normoblast, it gives reticulocyte. And the size of the reticulocyte is about 10 microns, and that is 8 to 10 microns it is. And the reticulocyte is also called as immature RBC or immature erythrocyte or young RBC or young erythrocyte. Because the size is about 8 microns, and whereas come to the erythrocyte size is about 7.2 microns. Everything is like the same as the erythrocyte. The only difference is presence of the nucleus in case of the reticulocyte, and that is disappeared in case of the RBCs. And here this reticulocyte which gives erythrocyte. So there is disappearance of the nucleus and complete formation of the erythrocyte. This is by the erythropoietin intrinsic factor and the vitamin B12. And the general factors like hypoxia, hypovolemia and anemia, or which are influences this erythropoiesis process. The lifespan of the RBCs is about 120 days. And next one is this red blood cells according to the size, so these are about 7.2 microns, and the biconcave shape is present. And if you see the thickness of the cell, in case of the middle that is about 1 micron, and in the edges that is about 2 microns, and the size is about 7.2 microns. That's what the diameter it is. And next one is the color is red in color, that is because of the presence of the hemoglobin, which is a color compound. And next one is the mean corpuscular volume, hemoglobin. In single cell of the RBC, how much amount of the hemoglobin is present is called as MCH. And next one is mean corpuscular hemoglobin concentration. The average presence of the hemoglobin concentration in total RBC is called as MCHC. And next one is, if you see the RBCs, these are in different shape, so abnormal shape it is. Okay, normally it is in biconcave shape, and abnormal shape we see, so that is in different cases like megaloblast, macrocyte, microcyte and normocyte. Normocyte in the sense normal size, macrocyte in the sense the size is increased, then the microcyte in the sense the size is decreased, and the sickle cell, the cell which is in the shape of the sickle like crescent moon is the sickle cell letters. And in case of the megaloblastic cell, the size is completely different and entirely so, and the cell is also like bigger than the normal size. And next one is another type is sickle cell. As we discussed, if you see this diagram, we'll come to know. So sickle shaped RBCs are present. And next one is so the erythroblastosis fetalis. In case of that, later we'll discuss this topic in the blood groups. Okay. And next one is erythrocytosis is nothing but it is also called as polycythemia. This polycythemia is nothing but the increased rate of the RBC count is called as erythrocytosis. That in the sense what? RBC count is increased. And physiologically this is in two types. One is absolute and the relative. So where it increases in the sense one is the age factor, and next is sex, gender, and next one is after meals, exercise, after exercise, and next diurnal variation, and during the sleep RBCs are decreased, and remaining time it is increased. And next, in case of the diurnal variation in the mornings and evenings, so in the evenings it is more and in the morning it is less. And next, if you see the pathological conditions, there is two types of the polycythemia. One is primary polycythemia and another one is secondary polycythemia. The primary polycythemia is nothing but the RBC count is only increased, and whereas come to the secondary polycythemia, including the RBC count, also hemoglobin is also increased. That is secondary polycythemia. And next one is erythropenia. In the sense the count is decreased, RBC count is decreased. This is mainly seen in case of the anemia. And next one, the causes are mainly whatever it is, maybe the decrease in the central factors or the general factors or the conditions like more destroying of the RBCs. Next is erythrocyte sedimentation rate, ESR it is also called as. That in the sense, so after collecting the blood sample, okay, so there are two types of the methods are there. One is Westergren method and another one is Winthrop's method. By these two, performing the hematocrit, that in the sense it should be stable, keep aside. So fill the tube and keep aside, and then the RBCs are get settled down is called as ESR. The normal range of the ESR in case of the men is about 2 to 10 millimeters per hour. In case of the female women, that is about 2 to 15 millimeters per hour. And next one is, if you see the factors which are influencing the ESR, like there are two types of the factors. So one is increased factors and the decreased factors. So when ESR increased, in the sense, when there is immune response, when the body is get infected, so such times the ESR is increased, and when it is decreased, in the sense during the anemic conditions. Okay, and next one is the hemolysis of the RBCs. The hemolysis of the RBCs is nothing but rupturing of the osmolytic facility of the RBCs. The causes mainly, so the rapid destruction of the RBCs and the hemoglobin. And next one, the causes are the mainly so due to the anemic conditions and the hypovolemia. And the hemoglobin which is present in the RBCs, if you see that there is 4 porphyrin rings are present and the iron is present, and the hemoglobin is a part nothing but the heme plus globulin. Globulin is a protein part, first class protein part, and the heme is a color compound. This color compound is by the iron component, it is in the state of the ferrous and the ferric state, stable and unstable forms. And the globulin is a protein part, it is, and 4 porphyrin rings are present. And if you see the structure clearly, the 4 porphyrin rings, and next to that attachment of the, so this ferric and the ferrous forms. And this hemoglobin is physiological role, if you see this, the transportation of the gases, and the normal range of the hemoglobin is about, in case of the male, that is about 13 to 15 grams per deciliter, and in case of the female it is about 12 to 14 grams per deciliter. And the compounds of the hemoglobin is mainly physiologically, it is in oxyhemoglobin. When the hemoglobin combines with the oxygen, that is called as oxyhemoglobin. Deoxyhemoglobin, in the sense when the oxygen is detached with the hemoglobin, is called as deoxyhemoglobin. And the carbaminoglobin, in the sense when the carbon dioxide is binds with the hemoglobin, is called as carbaminohemoglobin. And the components of the hemoglobin, carboxyhemoglobin, pathologically it is carboxyhemoglobin, carbon monoxide, and the methemoglobin, in the sense the methylene is component which is binds with the hemoglobin. And there are three types of the hemoglobins. One is fetal hemoglobin, HbS, that is which is present, HbF, which is present in the fetus. And there are two types of the chains are present. Two alpha chains and two gamma chains are present in this. And adult hemoglobin, in case of the adult, the hemoglobin which is present is called as adult hemoglobin. In this, two alpha chains and two beta chains are present. And next is primitive hemoglobin, HbP. So that is the, in case of the infants and the neonates, that is and the embryological stage of the fetus. This is contains, and two alpha chains and two epsilon chains are present in this. And hemoglobin is changing into the amino acid order, and another one is HbS. In case of sickle cell anemia, so the hemoglobin which is present in the sickle cell anemia is called as HbS, or nothing but hemoglobin which is present in the sickle cell anemia. And if you see the color index, this mainly which indicates the color of the RBCs, which represents the hemoglobin contained in the RBCs. We see the formula for this. Hemoglobin contained grams per deciliter, and that into 3 upon the first 3 numerals of the RBC count. And the normal range is about 0.8 to 1 unit, and if it is less than 0.8, that is called as hypochromia, that in the sense decreased hemoglobin, and it is greater than the 1, that is called as hyperchromia. And next one is the leukocytes. Another type of the cell is the leukocytes. So these are also called as WBCs. The size is varies in between the 9 to 12 microns, and the normal count is about 4 to 11 thousandths per cubic millimeter. And next one is the functions of this WBC is majorly divides into defense mechanism and the immune response and the antigen antibody reactions. And next come to the generation and the development of the WBC, that is what we call as leukopoiesis. This leukopoiesis is nothing but the pluripotent hemopoietic stem cell which gives committed pluripotent hemopoietic stem cell. And then there is development of the 4 types of the cells: CFUE which gives erythrocytes, CFUM which gives platelets, and CFEM and G which gives monocytes and the granulocytes, and CFUL which gives lymphocytes. And come to the last two, CFUGM and CFUL, which gives complete WBC types of the granulocytes and agranulocytes. In this, so after this, the CFUGM, then there is neutroblast and eosinoblast and basoblast and monoblast. These are also called as blastocyte for neutrophil and blastocyte for eosinophil, blastocyte for basophil, blastocyte for monocyte. By this, there is directly the cells will come like neutrophils and eosinophils, basophils and monocytes respectively. Another one is there, that is what CFEL, so colony forming unit L, which gives lymphoblast, and by that there is production of the lymphocyte. The leukopoietin is responsible for this process, leukopoiesis process. And role of the leukopoietins is these leukopoietins are produced from the liver and the kidneys, and the humoral regulation is regulated the leukopoiesis process. Next, the leukocytosis is nothing but the increases the size and the number of the leukocytes is called as leukocytosis. This is physiological variation and the pathological variation. In case of the physiological variations like age, sex, nothing but gender, after meals, pregnancy, lactation and exercise, sleep, all these are affected physiologically, and pathologically, that is which increases these levels is called as leukocytosis. And leukopenia is nothing but decreased WBC or the leukocytes is called as leukopenia, and the only pathological variation there, leukopenia. Individually, if the neutrophils are increased, that is called as neutrophilia, and decreased condition is called as neutropenia, and eosinophils increased condition is called as eosinophilia, and decreased condition is called as eosinopenia, and increased condition of the basophils is called as basophilia, and decreased condition is called as basopenia. And come to the agranulocytes, monocytosis increased condition, monocytophilia is decreased condition, lymphocytosis increased condition, and decreased condition is called as lymphocytopenia. Leukemia, the abnormal increased condition of the WBC is called as leukemia. It is also called as blood cancer. And if you see the types of the leukocytes, there are two types. One is granulocytes and another one is agranulocytes. In case of the granulocytes, there are three types. The granulocytes is nothing but presence of the granules in the WBC is called as granulocytes. These are in three types: neutrophils and eosinophils and basophils. Then agranulocytes are divided into two types. One is lymphocytes and another one is monocytes. And we come to the neutrophils. The neutrophils are about 47 to 72%. Juvenile bond is present, that is about 6%. Immature are 1%, and segmented is about 47 to 72%. And the neutrophils undergo for the first line of the defense mechanism. If you see the structure of this neutrophil, the lobes are multi-lobes are present in the nucleus. That in the sense 2 to 7 lobes are present in the nucleus. That in the sense nucleus is divided into 2 to 7 lobes. Okay, and next one is it is a type of granulocyte, so that the granules are present in this. And next one is neutrophils undergo for the phagocytosis process in the first line of the defense mechanism, and macrophagocytosis, respiratory burst like this. And next one is basophils. The basophils are the histamine cells, these are, and the heparin production is present in this. The basophils, in case of this, more granules are present in the basophils, so that the nucleus is appears properly. And next one is the nucleus structure is divided into two lobes, that in the sense, so that it is called as bi-lobed nucleated cell. It is. And eosinophils are also like two lobes are present in the nucleus, bilobed nucleated cell it is, and it is completely filled with the eosin, so that it is called as eosinophil or acidophil. And the functions, that is mainly undergo for the allergic conditions. It is responsible for the allergic conditions. And the eosinophilia is nothing but increased count of the eosinophils, and the decreased is called as eosinopenia. And next come to the granulocytes, monocytes. So the monocytes undergo for the phagocytosis process. The nucleus is in bean shape, and these are the largest cells in the total blood cells, that is about 18 micron size. And the monocytes and the Van cells, these are. And another cell is lymphocytes. There are two types. One is B lymphocytes and T lymphocytes, and another one is small lymphocytes and the large lymphocytes. And these are responsible for immunity. And next, so these lymphocytes, so the nucleus is in round shape. And diagnostic importance: increased neutrophils in case of the inflammations, increased eosinophils, allergic and the parasitic infections, and decreased eosinophils in case of stress, and increased lymphocytes in case of the cancer like leukemia. And come to the immunity. What is immunity? The capability to resist from the pathogens, antigens, and the responsibility is the takes by the leukocytes, WBCs. So it is nothing but the resistance of the body from the foreign bodies is called as immunity, defense mechanism. And if you see the types of this immunity, is divides into two types. One is innate immunity and another one is acquired immunity. Innate immunity is into two types. One is primary immunity and another one is secondary immunity. And the acquired immunity is by two types. One is cellular immunity and another one is humoral immunity. And if you see the roles completely innate, so come to the primary cellular and secondary humoral, so that is undergo for the like neutrophils, basophils, eosinophils, macrophages, NK cells and the phagocytosis process. And in case of humoral secondary immunity, that is by the lysosomes and the interferons and the complementary systems and the stomach acids and the tear and saliva, and next one is skin and mucous membranes are responsible for this. And acquired immunity is for two types. One is cellular immunity and another one is innate immunity. In case of this, it provides the cellular immunity is provided by the T cells, that in the sense T lymphocytes, and the humoral immunity by the B lymphocytes. And next, agglutination of the RBCs, that is by the hemagglutination. So the destruction of the RBCs is called as hemagglutination. It is mainly used in case of the blood typing and the quantification of the virus dilutions. And if you see the reactions, like, so when it mixed with the agglutinins, the RBCs get destructed, agglutination is present. If there is no agglutination, RBCs are in normal. And come to the agglutination, that is by the agglutinogen, presence of the agglutinogens and the agglutinins, antigens and antibodies, like, okay. So incompatible, this is mainly in case of the incompatible blood transfusion and the determining blood groups. And come to the blood groups. The blood groups are discovered by the so many persons, and in that the predominant one is ABO blood grouping system, that is called as classic blood grouping system. This classic blood grouping system is discovered by the Karl Landsteiner, and he got Nobel Prize in 1930s. ABO blood grouping system. And second one is RH factor, that is discovered by the Karl Landsteiner and Alexander Wiener, and Alexander Wiener also got the Nobel Prize in 1930s for the discovering this RH factor. And next one is, so there are types in this ABO blood grouping system, that is A, B, AB and O. So in case of O group, there is presence of the alpha and beta, and in case of the A group, there is beta is present, and in case of B group, alpha is present, and in case of the AB group, there is presence of the, so nothing, antibodies. Okay, come to this ABO blood grouping system. There are presence of the antigens and antibodies. Antigens are present on the surface of the RBCs and antibodies are present in the plasma. According to this, Landsteiner proposed two laws. One is, law 1, if there is presence of the one type of antigen on the surface of the RBCs, the corresponding or same type of antibody must be absent. And law 2 is, if there is presence of the one type of the antigen on the surface of the RBCs and the opposite type of the antibody must be present in the plasma. There are two types of the antigens are present and two types of the antibodies are present. Antigens are A, B and antibodies are A and B. According to the Landsteiner laws, if there is presence of the A type of the antigen, the A type of the antibody must be absent. That is law 1. And law 2 is, if there is presence of the A type of antigen on the surface of the RBCs, the opposite type, that in the sense B type of antibody must be present. According to these two laws, the blood groups are divided into 4 types. One is blood group A, blood group B, blood group AB and blood group O. If you see the blood group A, in case of this, antigen A is present and antibody B is present. And if you see the blood group B, antigen B is present and antibody A is present. And if you see the blood group AB, antigens both A and B are present and antibodies are nil. And next one is O group. In case of this, antigens are absent and antibodies are A and B, both are present. So that the antibodies are present in the O group, there is no antigen, so that these people can donate to anyone. That's why O group person is called as universal donor, and there is no antibodies in AB blood group and both antigens are present, A and B. These people can receive blood from any type of blood group persons. That's why this AB blood group is called as universal recipient. And if you see the donation and the receiving of the blood, A group person can donate blood to A group and the AB group, and these people can receive blood from A group and the O group. And if you see the blood group B, these people can donate blood to B group and AB group. And if you see the receiving of this B group persons, these people can receive blood from B group and O group. And AB person can receive blood from A group, B group, AB group and O group. And AB group person can donate blood to only AB group. And O group person can donate blood to anyone like A group, B group, AB group and O group. But these people can receive blood only from O people. And next, if you see another blood grouping, that is what RH typing. So this is the second predominant one. There is presence of the D type of antigen. There is no antibody here. If this D antigen is present, that is called as positive group, and if it is absent, that is called as negative group. D antigen is present, that is positive group, and D antigen is absent, that is called as negative group. According to these two, first ABO grouping and RH typing, so the blood groups are completely divided into 8 groups: A positive, A negative, B positive, B negative, AB positive, AB negative, and O positive, O negative. And 85% of the people belongs to RH positive itself. Okay, this is determined by the anti-RH serum. And next one is the positive persons can donate to only positive blood groups, and negative persons can donate blood to negatives and as well as positive groups also. That in the sense, O negative is a universal donor and AB positive is the universal recipient. This RH system is discovered by the Karl Landsteiner and the Alexander Wiener in 1920s. Next, so the RH incompatibility is in case of the blood transfusions and the second transfusions. And another one is erythroblastosis fetalis. It is the applied aspect of the RH incompatibility. So in case of this, if mother contains RH negative and the fetus is RH positive, then first birth, no problem at all. And in case of the second birth, during the first birth parturition, some amount of the blood is released through the placenta into the womb of the mother, and so that the D antigens are released into the womb. According to this, the antibodies against to that D antigen are produced in the mother, and in case of second birth, that is also RH positive, then there is maybe a risk of the fetal death in case of second birth. This phenomenon is called as erythroblastosis fetalis. And blood transfusion is according to the groups and the RH compatibility. This blood transfusion mainly by the cross matchings and the blood group matchings. So as I told you earlier, okay, and this blood transfusion, so when there is anemic conditions and during that the hypovolemic conditions and then there is a blood transfusion is needed. This is blood transfusion is by the direct and the indirect and the autohemotransfusions. After this, the rules of the blood transfusion, if you see, that is the compatibility of the blood groupings like ABO grouping and rhesus factor, RH factor compatibility, and next one is cross matching, that is by the direct and indirect cross matching properties, that in the sense some in the donor cells and the plasma of the patient is mixed. If there is any agglutination seen, the blood is not matched, and some cases the patient's cells mixed with the donor serum, if there is agglutination, that is not matched at all. Okay, and biological test for this cross matching and biological test like HIV, STD test, and any history of the previous cases. And another cell is in the blood is thrombocytes, nothing but the platelets. These platelets are the very minute cells, that is about 2 to 3 microns in diameter, and the normal range is about 1 to 2 lakhs is the normal range per cubic millimeter. Okay, the lifespan is about 8 to 12 days. The major function of these thrombocytes is coagulation and the hemostasis process, and platelet function majorly, that is what it undergo for the coagulation process. And thrombopoiesis, what is this thrombopoiesis? In the sense, the generation and the development of the thrombocytes is called as thrombopoiesis. The hemopoietic stem cell gives pluripotent stem cell. That pluripotent stem cell promegakaryocyte, and that promegakaryocyte developed and it gives megakaryocyte, and megakaryocytes which gives platelet cells. These platelets undergo for the coagulation process. The size of these platelets is about 2 to 3 microns. These are like slate-like, big brick-like structures, and that is about around 10 to the power of 11 thrombopoiesis per second. And reservoir of the platelets is in the spleen, and the Kupffer cells in the liver produces this platelets. After this, if you see the hemostasis is nothing but arrest of the bleeding, is called as hemostasis. This hemostasis is in under 3 headings. One is vasoconstriction, and next one is platelet plug formation, is nothing but platelet aggregation and adhesion, and third one is blood coagulation. If you see this vasoconstriction, first stage, when there is injury occurred, before the stage of the injury, there is vasoconstriction, by that the blood loss is decreased. And platelet plug formation, at the place of the injury, the platelets forms mesh-like structure and then arranged like a bricks, wall bricks. And after that, clotting factors, blood coagulation, third stage, that is clotting factors and the platelets gets activated, and those are adhered to that platelets, and completely clot is formed. And after this, the types is in 2 types. One is vascular thrombocyte hemostasis and coagulation hemostasis. Vascular thrombocyte hemostasis is involved in the first 2 stages, vasoconstriction and the formation of the platelet plug formation, and the coagulation hemostasis is by the 2 types, intrinsic pathway and extrinsic pathway, that is by the clotting factors. There are 13 clotting factors are present which involved in the coagulation process. Okay, so first come to the vascular thrombocyte hemostasis, the constriction of the blood vessels, that is what the vasoconstriction, and after that thrombocytes are forms brick-like structure, and that is what the vascular thrombocyte hemostasis. And next one, cellular clotting factors like ADP, ATP, ionized calcium, serotonin, and epinephrine, thromboxane A2. And 13 clotting factors, those are different again. And if you see the coagulation, third stage of this, that is divides into 2 types. One is intrinsic pathway and extrinsic pathway. If you see the intrinsic pathway, when there is injury occurs, immediately there is activation of the factor number 12, that is nothing but Heisman factor. And activation of this 12th factor, it activates 11th factor. 11th factor is plasma thromboplastin. And activated 11th factor activates 9th factor. 9th factor is Christmas factor. And this activated 9th factor activates 10th factor in the presence of the calcium, 4th factor. And this 10th factor activates the thromboplastin or nothing but the prothrombin activator. This is the intrinsic pathway. And if you see the extrinsic pathway, so when there is major injury occurs, major trauma occurs, immediately the cell membrane of the thrombocytes or platelets, there is two types of the proteins are present. One is glycoproteins and another one is lipoproteins. These two gets activated and they binds with the calcium and it activates directly 10th factor. And this activated 10th factor activates the prothrombin activator. That is the stage 1 of the coagulation process. And if you see the stage 2, in that there is activation of the prothrombin. In the presence of the prothrombin activator, which is activated either by the intrinsic pathway or the extrinsic pathway. In the presence of that prothrombin activator, prothrombin is converted into thrombin. This is the stage 2 process. And in case of the stage 3, there is fibrinogen conversion in the stage 3. In the presence of the thrombin, which is activated in the stage 2, in the presence of the prothrombin activator, that is the thrombin. In the presence of this thrombin, the fibrinogen converts into the fibrin, loose fibrin threads. And these loose fibrin threads binds with the calcium, and then there is activation of the fibrin loose threads and it make a tight clot. That is what the coagulation hemostasis process. If you see the summary of this coagulation process and the hemostasis, and that involves in 3 stages, that is activation of the prothrombin activator, and the prothrombin converts into the thrombin in the presence of the prothrombin activator, and stage 3 is nothing but the fibrinogen converts into the fibrin in the presence of the thrombin. This is the coagulation process. And next one, fibrinolysis. Fibrinolysis in the sense the destruction of the fibrin clot is called as fibrinolysis. This is by the tissue plasminogen activator and the plasmin, and next one is factor 12A kallikrein. By all these, the fibrin degradation and converts into the fibrin. Next one is, if this fibrinolytic system, after complete formation of the clot, so when there is the tissue comes to the normal, and then there is a fibrinolytic system gets activated by the plasmin. After this, if you see the anticoagulants, nothing but, so which stops the clot, prevention of the clot is the major function of this anticoagulants. These are in 2 types. One is in vitro, in vivo, nothing but natural and artificial. The natural, which are present in the body, like heparin and antithrombin 2. Artificial, like EDTA, sodium citrate, dicomarin, peloton, or double oxalates, all these are comes under the artificial type. Inactive clotting factor 3 is also one of the anticoagulant. And next, if you see protein 3 anticoagulant pathway, so that is by the PAI system and clotting factor 8 system and 5A system. By all this, it undergo for the, so this anticoagulatory pathway, which binds with the calcium directly. It binds with the calcium, and then there is anticoagulant mechanism. If there is no calcium in clotting pathway, in the sense that is completely stoppage of the clotting. That is the major phenomenon of the anticoagulant mechanism. And next one, clot prevention by the, when there is venous flow and the lower extremities, and the stasis of the blood, it undergo for the two functions. One is bleeding and no thrombosis formation. That is what the clot prevention mechanism. After this, the regulation of the hemostasis is by two ways. One is sympathetic nervous system and another one is by the parasympathetic nervous system. By these two ways, sympathetic and parasympathetic nervous systems, the regulation of the hemostasis is possible, where the vasoconstriction and where the platelet aggregation and adhesion, platelet plug formation, and how the blood coagulation, how the activation of the clotting factors and the intrinsic pathway or extrinsic pathway, selection of these pathways, that depends upon the type of injury and severity of the injuries. This is what all about the blood as per my knowledge. Thank you very much.